6.1 is about areas between curves. Let's review the notion of integration. Let's suppose that we have a curve whose values are positive between A and B. The curve is y equals f of x. When we think about the integration from A to B, f of x dx, that is the area under the curve. So this area we can understand that as area between the curve y equals f of x and y equals 0, meaning x-axis. So this is the x-axis. Of course, we assume that the function is continuous. What we want to think about today is area between curves. So in this setting, instead of thinking about y equals 0, which is a particular curve, we will think about any curve. And then we will think about the area between two curves. The question is, how about the area between two curves? Let's assume that we have two curves, f of x and g of x. And we assume that f is greater than g for all x between a and b. So circumstance looks like this. Let's suppose that this is f. This is y equals f of x. And this one is y equals g of x. We think about the region x equals a to x equals b. As we did when we defined the integration, what we will do will be we will draw a lot of rectangles. Between a and b, g of x is smaller than f of x. And when we think about the width of each rectangle, that can be expressed as delta x. And we pick any random point between these 2 points and denote it as xi star. Then the length of the dotted line can be calculated by the differences between two functions. That can be written as f of xi star minus g of xi star. Because f is bigger. When we approximate the area, what we did was we took limit n goes to infinity, summation I equals 1 to n, f of xi star minus g of xi star times delta x. Here, as I explained, delta x is width. And when we think about this, the length of the rectangle, that is the difference of two functions. So height of a rectangle. When we multiply the width with the height, that is the area of the rectangle. Here, this number n is the number of rectangle. We think about n goes to infinity. That means the number of rectangle becomes larger and larger. So rectangles become slim. So it'll be almost like a stick, just a vertical line. When the circumference goes like this, we use the stretched s, meaning sum, and that is the integration notation. We are thinking about the rectangle located between a and b, so lower bound is a and upper bound is b, and the larger function is f of x and smaller function is g of x. We subtract larger from the smaller from the larger, dx. That is area between two curves. Let's do some example. Find the area of the region enclosed by y equals x squared and y equals 2x minus x squared. The problem is saying that we have to figure out the area of the region enclosed by two curves. So that indicates that the two curves will be meet each other and form an enclosed area. So the first thing we have to do will be finding the intersection point. At the intersection point, y values must be the same. So we will put these two equal. So x squared equals 2x minus x squared. We add x squared on both sides. Then we get 2x squared, and we move 2x to the left. Then we have to subtract 2x on both sides. We divide by 2 on both sides, then 2 will vanish. So we have x squared minus x equals 0. The common factor is x, so x times x minus 1 equals 0. So x equals 0 or 1. So intersection point will be x value equals 0, then y value equals 0. And this is from 0 squared. X equals 1, then 1 squared is again 1 from this equation. We can easily figure out the graph of this one. Let's figure out how the graph of this parabola look like. If you factor this, then we have to take out the common factor, which is x. Then we have x times 2 minus x. From here, we get the x-intercepts. X-intercepts are 0 and 2. And in parabola, axis of symmetry is located between midpoint of x-intercepts. So it becomes x equals 1. Another important point you can observe from here is this is the top degree in quadratic equation. And there is negative attached here. That means parabola is concave down. Let's visualize. X-intercepts are 0 and 2, 1, 2, and the axis of symmetry is x equals 1. So concave down and passes through the 2 points. The peak point that is at 1. And this point is 1 and 1. If you plug 1 here, then 2 minus 1 will make 1. So y value is 1. Indeed, this is the intersection point with y equals x squared. Y equals x squared is just a parabola which is concave up. Looks like this. So what they're asking you to do is figuring out the area between two curves here. When we integrate, the lower bound should be put 0 and upper bound should be put 1 because this is the larger point at the intersection point. Let's set up the integration. A equals from 0 to 1. In this region, x squared is smaller than this function. So we will subtract x squared from 2x minus x squared. Let's do it. So 2x minus x squared minus x squared dx. So this becomes from 0 to 1, 2x minus x squared minus x squared is minus 2x squared dx. Two are common factors, so we can take that out, write down in front of integration. 2 times 0 to 1, x minus x squared dx. What we learned last time was when we have multiple terms, we do term by term integration. The first one is actually 1 power. We apply the power rule, then 2 times, this is x to the 1 more power, x squared, divided by the same number in the power, over 2, minus x to the 1 more power, which is x cubed, divided by the same number in the power. From 0 to 1. So 2 times x is 1, so 1 squared over 2 minus 1 cubed over 3 minus, open parenthesis, 0 squared over 2 minus 0 cubed over 3. And then the second part will vanish. And the first part will be 1 over 2 minus 1 over 3. We think about the common denominator, then that is 6, and we do cross multiplication in this case, then 3 over 6 minus 2 over 6. So that is 2 times 1 over 6, 2 is 2 over 1, so 6 is 2 times 3, they will cancel each other, so it becomes 1/3. 1/3 is the final answer. In this question, what we did was we visualized the graphical shape, and by looking at the graph, we determined which one is larger in the enclosed region. However, when we think about the area, the premise is area is always positive. So if something is unclear, then you can just calculate the differences between two curves. And if the answer is negative, then all we have to do is just dropping the negative sign. So area can be described as integration a to b, absolute value of f of x minus g of x dx. This is the area between y equals f of x and y equals g of x, and between x equals a and x equals b. That is another way to describe what I told you. If the consequence becomes negative, then you just drop the negative sign to answer the area between two curves. The next one is find the area of the region bounded by y equals sine of x and y equals cosine of x, and x equals 0 and x equals pi over 2. Let's review the trigonometry a little bit. The graph of the sine looks like this. That oscillate between -1 and 1. Characteristic of sine is a wave function, oscillate between -1 and 1. The period is 2 pi. And most importantly, it passes the origin. So it looks like this. This is pi, this is 2 pi, this is one cycle. But when it comes to cosine, everything is very similar. Cosine oscillate between -1 and 1. But cosine start at the highest point, so it starts with at 1, and it just oscillate as a wave function. The period is still 2 pi. So the first intersection point is pi over 2, and this is pi, 3 pi over 2, and this is 2 pi. Another important thing is when we differentiate cosine of x, then we have minus sine of x. If we differentiate sine, then we get cosine function. That means if we integrate sine, then we will get minus cosine. If we integrate cosine, then we will get sine. In the trigonometry course, you also learned about the triangular identity with 45, 45, 90-degree triangle. This is pi over 4. Then this is 1, 1, square root of 2. So here, the sine of pi over 4 is opposite. This is opposite. This is adjacent. So opposite over hypotenuse, which is 1 over square root of 2. And cosine of pi over 4 is adjacent over hypotenuse. Again, that is 1 over square root of 2. This is opposite over hypotenuse, and this is adjacent over hypotenuse. So from here, we can conclude that sine of pi over 4 and cosine of pi over 4 are the same. Let's go back to the problem. We want to find the area of the region bounded by sine function and cosine function and x equals 0 and x equals pi over 2. We will draw another graph. This time we will draw the sine and cosine function together. We know that both functions are oscillating between -1 and 1. We think about sine first. We draw sine first. This is y equals sine of x. Let's draw the cosine function. Cosine function looks like pi. This is pi over 4, and this is pi. So this, and then meet again here. This is y equals cosine of x. All we have to care about is between 0 and pi over 2. That is here. This is pi over 2. I made an intersection point at pi over 4 because of this. So by looking at the graph, what we realize is between 0 and pi over 4, this red graph is larger. So cosine is larger than sine. Between pi over 4 to pi over 2, we think about this region. In this region, sine is larger than cosine. Let's say this is area 1 and this is area 2. And what we will do will be, we will calculate area 1 and area 2 separately, and then we will add them together later. Area 1 start from 0 and end at pi over 4. I said cosine is larger, so we subtract sine from cosine. So cosine x minus sine of x dx. We integrate separately. If we integrate cosine, then we will get sine. Sine x. If we integrate minus sine, we will get cosine. So we have to add cosine. We think about 0 to pi over 4. So sine of pi over 4 plus cosine of pi over 4 minus, open parenthesis, sine of 0 plus cosine of 0. Sine of pi over 4 is 1 over square root of 2, and cosine of pi over 4 is 1 over square root of 2. Sine of 0 is 0, cosine of 0 is 1, so minus 1. If we add the 2, then that is 2 square root of 2 minus 1. 2 can be obtained by multiplying square root of 2 twice. So we can rewrite 2 over square root of 2 as square root of 2 times square root of 2 over square root of 2. Then those 2 will cancel each other, so we get square root of 2. So the final answer is square root of 2 minus 1. Let's do the similar calculation for the second area. Second area ranges between pi over 4 to pi over 2. In that region, this black graph, which is sine, is larger than cosine. So cosine will be subtracted from sine. So sine of x minus cosine of x dx. If we integrate sine, then we get minus cosine. If we integrate cosine, then we will get sine. So we have to minus came from here. So minus sine x. From pi over 4 to pi over 2. So that is minus cosine of pi over 2 minus sine of pi over 2 minus cosine of pi over 4 minus sine of pi over 4. Let's evaluate. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So we write minus 1 from the first one. And minus cosine of pi over 4 is 1 over square root of 2 minus sine of pi over 4 is again 1 over square root of 2. So we have minus 1 minus 2 square root of 2. We know that this is square root of 2. So we have 1 minus 1. This one is minus, right? So minus will make plus. So square root of 2. Minus 1 plus square root of 2. This minus came from here. Obviously, this is greater than 0, and also this is greater than 0. To conclude the problem, we have to add those 2 areas. So A equals A1 plus A2. A1 came out to be square root of 2 minus 1 plus A2 came out to be minus 1 plus square root of 2. So that is 2 square root of 2 minus 2. Okay, let's do just one more problem for today. Find the area enclosed by y equals x minus 1 and y squared equals 2x plus 6. Firstly, we want to figure out the graphical shape of the second equation because this one is just a straight line. This is parabola because we have y squared, but it is not the function of x. It is, we can regard this as function of y. If we solve for x, let's solve for x. We subtract 6 on both sides. Then we have y squared minus 6 on the left side, and we have 2x on the right side. So x equals 1 over 2 y squared minus 3. Just we divided it by 2 for each term. This is the parabola. But we are thinking about the parabola, which is defined as function of y. So it is either this one or this one, but we know that this is positive. So we can easily figure out that that should be this one. So the graphical shape looks like this. And what we know is when y equals 0, then x equals minus 3. So x-intercept is minus 3 right here. And what are the y-intercepts? Y-intercept happens when x equals 0. So y squared equals 2 times 0 plus 6. So y squared equals 6. So y equals plus or minus square root of 6. So this is square root of 6, and this is minus square root of 6. So this is the graph of this function, and we know that this function is increasing, and the slope equals 1, right? So it should look like something like this. This graph is y equals x minus 1. So this is minus 1. What we want to do is we want to calculate this intersection point and this intersection point. In the second equation, we solved for x. So we want to solve this for x and then make things equal. As I said, we had x minus 1, y equals x minus 1. So x can be y written as y plus 1. And then we make these two equal. So 1 over 2 y squared minus 3 equals y plus 1. And then we multiply by 2 on both sides. Then the first one will become y squared minus 2 times 3 will make 6 equals 2y plus 2. So we have y squared minus 2y minus 8 equals 0, we move this to the left and we subtracted 2i on both sides. We know that 2 times 4 will make 8, and if we put minus, then it'll make minus 8, and when we add them up, it'll be minus 2, which is the same number in front of y. So factoring goes y plus 2 times y minus 4 equals 0. So y plus 2 equals 0. That means y equals minus 2. And y minus 4 equals 0. That means y equals 4. For the intersection point, x is y plus 1. So when y is minus 2, x equals 1, minus 1. And when y equals 4, x equals 5, because that is just 1 more than y. So we figured out the intersection point. This is x minus 1 and y minus 2. For this one, x is 5 and y equals 4. The area we are thinking about is this part. But we solved for x, so the kind of rectangles we have to locate will be horizontal rectangle. So instead of thinking about delta x, this time we are thinking about delta y. That means the integration should be set integration dy, and the range you have to write down here will be y range. So y range is from -2 to 4. So -2 to 4. And the equation looks something like this. Let me write it down again. So area A is from -2 to 4. The y plus 1 in this region, the x value of this red graph is larger than black graph. That means this straight line is larger than the parabola. So straight line minus parabola, y squared over 2 minus 3 dy. So this one becomes -2 to 4. And y plus 1 minus y squared over 2 plus 3 dy. That becomes straight from integration from -2 to 4 minus y squared over 2 plus y plus 4 dy. And then we do just a term by term integration. Then -1 over 2 comes from here, and y squared will be integrated into y cubed over 3 plus y to the 1 power. So y squared over 2 plus 4 times y from the formula. We evaluate from -2 to 4. I do believe you can proceed on the mechanical calculation from here, because all you have to do is plugging in and subtract. After you go through all the calculation, you have to get 18. This is the last problem I wanted to present, and we will continue tomorrow with more complex problem. If you have any question, then you can ask me question. Otherwise, you can leave.